Well, we are here at Faurei testing in Romania, and we are testing our ABA test system that we developed at Delft University of Technology. ABA stands for Axle Box Acceleration, and that's exactly what it does. We are measuring the acceleration of the axle box, and that is this part that contains the wheel bearing of the train. We are measuring in different directions the vibrations of the axle box. And we do that by putting small sensors, you can see them here. We mount them on the axle box. They can measure in the vertical, longitudinal and lateral direction. These vibrations give us information about the behavior of the rail, the rail construction, when it is excited by the wheel of the train. And each vibration gives information about the type of defect and the size of it. What we try to do is to find the fingerprint of each defect. If we have found a certain defect and we are measuring it, let's say every 4 weeks, of course we can see the development of the defect. Is it growing? Is it stable? Or sometimes it can be disappearing because of wear. So with the ABA system we can see what the condition of the track is and if maintenance is necessary and when it is necessary. Yes, for us it was really exciting to run at and to measure at 200 kilometers per hour, because in the Netherlands we can go up to 100-140 kilometers per hour. And as the response of a defect also depends on the speed, because that's the excitation that you and the energy that you put into the system. The fingerprint will change with speed. So to calibrate the ABA system, it is important to do it at different speeds with the same defects. And at the test ring here at Faurei we are able to run different measurement runs on the same track with different speeds. And so we can compare the differences between speed and the fingerprint that we find.